So I guess this is kind of like an extended version of the previous part 3 to the Is the King in Check series of videos I've been creating. This is quite a detailed deep dive into the concise version of the vector solution that I came up with. I separated this out from the original video because it was a bit rambly and heavy and probably doesn't add a great deal of value in terms of elegance. But nonetheless, there's some stuff in here that might be of interest. So I'm going to post it anyway as I've recorded it. But yeah, enjoy or just don't watch it if you don't want to go into the nitty gritty of this ridiculous little rabbit hole that I decided to tumble into. I did go on to further improve / ruin the elegance of the solution by making it much shorter, kind of trying to find commonality between things like this. Some of it is quite similar, particularly here, for example. There's a bit of repetition that I thought, hey, I could probably compress that down into something even more elegant and beautiful. But alas, I don't think I could call that elegant and beautiful. It kind of made it look pretty horrible, in fact. I'm not going to fully explain it, not least because I can hardly remember how it works, actually, because it's been a while since I did it. But you can see these two maps that we had before. I'm doing something kind of crazy with the magnitude of the vector. I'm multiplying by 9 and taking the floor of that so that we get an integer value. Roughly speaking, the possibilities for the integer vector values are on this grid: 0, 9, 18, yada yada yada. And I kind of figured that most of these are pretty much unique. Certainly for the lower values, they're all pretty unique. And for a knight, for example, rather than needing square root of 5, you just need to have a value of 20. And for a pawn, rather than root 2, a value of 12. So that gets used later here, where we're checking that the magnitude of the vector is 20. And here, n is equal to the index of the piece, which is 0 for a knight. So this resolves to 0, meaning that the magnitude must be 20. And for a pawn, n is equal to 1. So 1 times 8 is 8. 20 minus 8 is 12. Therefore, this conditional check matches the distance expected for a pawn. And then we also, for the case of a pawn, we're checking the angle, because the angle for a pawn, previously we were checking specific angles, but actually if you think that it must match that distance, and if it's a positive angle, then that works as well. So yeah, angle times by n, which for a pawn would be 1. If that's greater than 0, then it passes that check as well. Now for a knight, obviously, n would be 0. Anything times 0 is going to be equal to 0, so that will pass the check for a knight. Now, how does it handle all of the other pieces on this line? Well, that's kind of where I was kind of a bit creative with this. If this index of resulted in a value that is beyond a knight or a pawn, it would be 3, 4, or 5. And if it's 3, 4, or 5, 20 minus 3 times 8, 4 times 8, or 5 times 8 will result in a negative number, and the magnitude will never be a negative number. So this actually covers the logic for a knight and a pawn without any interference of these other pieces as well. What else can I say here? L if L equals a space, then I'm just, rather than having the filtering that I had where I was filtering out kings and spaces, instead I'm basically doing the same thing by setting the magnitude of the vector to an artificially large value if it's a space. I don't know what I'm doing with kings. Must be doing something with kings. Oh yeah, kings are covered anyway, I think, because it will not be in this list. So that is probably how kings are handled. Why wouldn't that handle this then? Anyway, I'm not going there. Maybe it is handled. Maybe I didn't need that check. Oh no, this is how we deal with kings. I remember now. If this resolves to a value of 0, which it would be, bearing in mind we're calculating the distance to the king's distance to the king is 0. So the hypotenuse equals 0. And if it's 0, I'm doing OR, so it's a falsy value, and then I'm artificially setting the distance for the king to itself to 99. Therefore, it gets addressed with this sort. Yeah, and I think that sorts that out. That probably covers most of it. Yeah, I somehow merged the bishop, rook, and queen together. I'm going to be honest and say I can't really remember how this works. But I went through a series of kind of gradually making logical changes to it. N is greater than 2. Well, that's obvious. That N is, it must be one of these pieces then. Math.abs of A, or A is an angle, which will be, oh yeah, that's something cool I did as well. I invented my own unit of measurement for angles. Instead of using 180 degrees, I'm now mapping it to a value between +4 and -4. So that's pretty cool because, yeah, if we only really care about the integer values 1, 2, 3, 4, and -1, -2, -3, and 4, which would be roughly equivalent to all of the 8 diagonal, sorry, all of the 4 diagonals and the 4 horizontal and vertical axes. So I thought that was pretty cool. And then I can take the absolute value of the angle. Okay, cool. Modulo n minus 3, right? So that's converting the index of to now be a 0, 1, or 2. 0, 1, or 2. Right shifted. 0, 1, or 2. Oh, yeah, I remember. I was doing some bitwise thing. I created a truth table because if you think about, what was it in here? I can't remember exactly what I did. See if I can find it. Yeah, I don't have any of my intermediate steps for that, which is a shame. 1 second. So I'm stripping off the rightmost bit, which means 0, 1. Yeah, okay, so it's going to be, okay, 0, 1. Yeah, so we're targeting queens here then. N minus that. Okay, so if it's a queen, we -1. If it's not a queen, then it's 2. Okay, so if it's either a, if it's, yeah, so this resolves to 2 for bishops and rooks and 1 for the queen. Now this is kind of adding up, I think. Right, 2. Yeah. Yeah, so if this is a value between 0 and +4, 0 and -4, then we're doing modulo 2 or modulo 1. Now, if it's modulo 1, then that would be for a queen, right? Yeah, 2 minus this thing, which we said would target queens. So for a queen, we do modulo 1. For a rook and a bishop, we do modulo 2. So yes, so if we had 0, 2, or 4 as the angle, or minus 0, 2, or 4 as the angle, and we do modulo 2, that's going to find rooks. If it equals n minus 3 modulo 2 again, modulo 2. So if that is 0, okay, so that'll be 0, 1, 0. Yes, okay, this is clicking, I think. 0, 1, 0. So we're expecting a value equal to 0, 1, or 0. Yeah. Okay. So rook, considering a rook, we have 2. Yeah, so we have an angle between 0 and 4 using my invented units, modulo 2. So the things that would be relevant for a rook would be an angle of 0, 2, or 4, or minus 2, minus 4. So taking the modulo of 2 of that, you would end up, if it is on one of those angles, you would end up with a value of 0. So here we would need to check that it equals a value of 0, which for n minus 3 is a rook. Modulo 2 is 0. So if 0 equals 0, then it passes that check, and therefore the rook is giving the king check. Bishops. So with a bishop, again, this resolves, we're stripping off the rightmost bit, which would be 0, 1 for index of, n minus, that would be a value of 1. No, it wouldn't, sorry. It would be 0, 1. We strip off the rightmost bit and we'd end up with a value of 0. So 2 minus 0 is 2. Then we're doing an angle check here. So we're taking the absolute value of A, so making sure that it's positive. Then we are, so the relevant angles in my invented degrees system for a bishop would be 1 and 3. Because, it's between 0 and 4. So 1 and 3. So this would be modulo 2. So we're going to have an angle here. Let's say the angle is either a 1 or a 3. Both of those, if you take the modulo of 2, would equal a value of 1. Because that would be left over if you did 1 divided by 2, the remainder would be 1. 3 divided by 2, the remainder would also be 1. And that is consistent with this as well, because n minus 3 would equal 1 for a bishop. Bishop modulo 2 is 1. So if 1 equals 1, then the bishop is giving the king check. Good. Queen, then. Now, this is where this logic is relevant for the queen, because we have n minus 3. So n, 0, 1, 2, 3, 4, 5 for the queen. 5 minus 3 is 2. 2 represented as a binary number is 1, 0. Strip one digit from the right, we end up, rather than 1, 0, we strip that 0, we end up with 1. This equals 1. Therefore, 2 minus 1 equals 1. So now we're doing math.abs of the angle modulo 1 rather than 2. So that means any of the increments from between 0, 1, 2, 3, 4 in my invented degrees system, any of those 45 degrees in actual degrees would match that modulo 1 thing. So yeah, any of those increments, 1, 2, 3, 4, would be the things that we're looking for here for a queen. Now, n minus 3 would be, we've done that already. That's 5 minus 3 modulo 2. Yes. Modulo 2 would equal 0. So if this angle is either 0, 1, 2, 3, 4, and we take the modulo of the value 1, we're going to end up, if it's on one of those expected angles, being a 0. So if 0 equals 0, then the queen is giving the king check. That's how it works. Whew. Need a drink. So yeah, that's how I compressed it down. What a ridiculous task that was. But I enjoyed it. I was pursuing a more elegant solution, but I think I created a monster. This looks pretty horrendous, and I think the original solution here, it reads quite beautifully, I think. And you know, if I say so myself. Anyway, I'm pleased with it, and I hope you enjoyed this video. Please subscribe if you haven't already. I'll try to do more videos as soon as I can. So yeah, please comment if you have any questions, queries, or anything you'd like to say. I love hearing from you all. And with that, I will catch you later.